All right, now we want to just take a moment and talk about, we talked a little about concentrations, we talked about partial pressures. I want to consider reactions where I have different phases of things. I have gases and aqueous, or I have solids, or I have liquids in them. And how does that affect? So most importantly, when we talk about heterogeneous equilibria, we're involving reactions that involve solids or liquids in state. Remember, when we talked about the Kc, we're writing in terms of concentration. The concentration is the ratio of components in a mixture. But solids and pure liquids only have one component. Therefore, their ratio is always unity, 1. So in other words, they don't have a concentration. Their concentration is 1. They're pure. I can't rate, remember, we talk about moles of solute divided by volume of the whole thing, of the mixture. I can't have that when I have a pure substance. So for pure substances, their concentration is 1. Because of that, we will not include solids and liquids in the Kc or K expression. So they drop out. It turns out and you can think of it in other ways, that because they're pure, they don't change. The concentration is not going to change, and therefore it's not going to affect it. So the only things that I care about when we're writing these K expressions are aqueous and gas state substances. So let's look at this example. CO2 in gas state plus water in liquid state. So this would be pure, makes H plus aqueous plus HCO3 minus aqueous. The only things I care about are the gases and the aqueous. So when I write this Kc expression, it's the concentration of the products, H plus and HCO3 minus, multiplied together. They have no coefficients, so there's no powers in this one. And then for the reactants, note that I'm only going to put CO2 there. I'm not going to put the water because the water is going to have a concentration of unity, so I leave it out. So I ignore the liquid state substances when I'm writing my K expression, and that's going to make life a lot easier. So here's a couple of different examples. This one has gases and solids. So I'm going to ignore the solid. This one would just be, in terms of the Kc, in terms of concentration, with the concentration of CO squared divided by the concentration of CO2. I would leave this out. If I were going to write it in terms of Kp, in terms of partial pressures, it would be the partial pressure of CO gas squared divided by the partial pressure of CO2. So I can consider it either way, since this is gases involved. Same thing over here. This is also solids and gases. Note that I have solid F3O4 and I have solid Fe. They're not going to appear in it at all. I'm only going to be concerned about, in terms of concentration, the concentration of water, because it's in gas state, raised to the 4th power, over the concentration of hydrogen raised to the 4th power. Or if I were to put it in terms of a partial pressure, it would be the partial pressure of water raised to the 4th power and the partial pressure of hydrogen raised to the 4th power. Depending on the problem, whether it's asking for Kc or Kp, would be how we would set those up. But I'm going to ignore solids. I'm going to ignore liquids as well.